Hey Martin, so this is going to be my first attempt at recording a video. There's probably going to be lots of problems with this, but we'll get better as we go. So what I want to do in this video is go over the question three, which I think you were struggling with. So whoops, I'm getting used to this pen situation as well, which is kind of strange. So you'll have to bear with me. So question three says, find all pairs of positive integers whose sum and product add to 2011. Okay, so that is, if we take x and y in positive integers, again, my handwriting will get better, but for now, hopefully it's legible. So I'll use notation and explain as I go. This means um, is an element of, is an element of. So that's like if you have a set, then it says x and y, these two things, are both in this set. And in this case, the set we're dealing with is the positive integers denoted z plus. So this is positive integers, z plus, positive integers. Okay, so now back to the question. Find all pairs of positive integers whose sum and product add to 2011. So we've got our pair of positive integers here. So their sum is given by x plus y, and their product is given by xy. And it says find all possible pairs of positive integers whose sum and product add to 2011. So we want something where the sum of this is equal to 2011. Okay, so the first thing to notice here, I would say, is I'm doing. Sorry, I should have explained earlier. I haven't thought about the question before. I'm just doing this one live. I don't think I'll do this normally, but maybe it's interesting for you to see how I would approach the question. So so in this case, my first idea would be to try and factorize the left-hand side somehow, and with experience, this gets easier. So straight away, I observe that the left-hand side factorizes in the following way. You can check this by expanding the brackets, but this is a pattern that will become familiar to you. So this is x plus y, x plus 1, y plus 1, minus 1 is 2011. So then we add the one to this. This becomes 2012. So we have x plus 1, y plus 1 is 2012, where x and y are both positive integers. And so they must both each be factors. So now we want to consider the factorization of 2012. Well, 2012 is, let's see, it's 2 times 1006, which is, so 2 times 1006 is 2 times 2 times 512, which is, sorry, I think it's going to be easier for me to write out. What's going to be the best? What's the best way to do this? Okay, let's do it a step at a time. Times 512, which is, I'm going to have a scrolling issue in a minute as well. I've not worked out how to scroll. Okay, we'll carry on. We'll try and write small. So 512, that's 2 times 256, which is 4 times 120. Oh wait, is this a power of, wait, something's gone wrong. It's not 512. I'm getting confused with powers of 2. My bad. Okay, this is 2 times 1006, which is, 2 times 503, I think. Sorry, 4 times 503. Sorry, this is getting messy. Let me write it out again. Okay, this is 4 times 503. Is 503 prime? I think 503 might be prime. Well, to check if a number is prime, it suffices to check up to the square root, right? Because if you have, let's say take 400, then the square root of 400 is 20. And any number higher than 20, the number you would pair it with for the product to be 400 has to be less than 20 if one of them is greater than 20, right? Think about that, and hopefully that will make sense to you why. So if we want to see if 503 is prime, then we need to check all of the primes up to the square root of 503. Okay, or if the square root of 503 isn't an integer, then all of those less than it, right? So I mean, the square root of 503 is going to be bigger than, let me think. So 20 squared is 400, 25 squared is 625. Again, you will learn these with experience. So I think it's like basically 23, something like that. But 23, I don't think divides it. But okay, let's check up to 23. Okay, this is poor notation. I'm not sure about that. So we will check up to 23 because we know that will cover all the possibilities. So check up to 23. Okay, so 2. So we check all the primes. So 2, no, doesn't divide it. 3, no, because the sum is 8, which isn't a multiple of 3. 7, no, because 490 divides 7, and the difference 503 minus 490 is 13. 7 doesn't divide 13. 11, 440 is divisible by 11. 503 minus 440 is 63, which isn't a multiple of 11, so we're fine. 13, 390, 503 minus 390 is 113. No, because 130 is divisible. 130 minus 130 is 17, isn't a multiple of 13. 17, 510, nope, 510 is a multiple of 17. 19, 3, 570, 570 minus 503 is 67. I'm doing way too much talking. I should be doing more writing, but you can give me feedback on this afterwards. So 570 minus 503 is 67. Does 19 divide 67? Nope, it doesn't. Okay, then 23 is 460. 460 plus 43. 23 doesn't divide 43. So no, so 503 is prime. Okay. So then we need, so this is a prime factorization. So if we want to split 2012 into 2 factors, then we're going to have, so the possible factors are, the possible ways of splitting up to a product of 2 things are 2 times 1006, 4 times 503, and that's it, I think, yeah. Okay, so then obviously we can have these each way around, so that we would say x and y are kind of symmetric in that sense, because for each value x can take, y has a corresponding pair according to the equation we've just written down, so expressions rather than equations. But obviously we could switch the values of x and y around, if that makes sense. So again, looking back to the question, find all possible pairs of positive integers whose sum and product add to 2011. So we could have x plus 1 equals 2, i.e. This means implies x equals 1. Or we could have x plus 1 equals 4, which means x is 3. And then for these values we would have y plus 1 is 1006, so y is 1005. And here y plus 1 is 503, so y is 502. And then we can swap. So y can take the value of, x can take the value of 1 and 3, or it can take the value of 1005 and the value of 502. And we want all possible pairs. So there we go. You can write this up as 4 lines rather than 2, but I mean, you can interchange them. So yeah, all the pairs are x is 1, y is 1005, x is 3, y is 502, x is 1005, y is 1, or x is 502 and y is 3. Okay, so I hope that was not too bad and vaguely understandable. That was much longer than I thought it would be. So I'll have a think for next time, but if you could let me know what you think I could do to make it clearer and better, other than my handwriting and learning how to scroll, then that would be great. Okay, cool.